Okay, so welcome to your first video in AP Chemistry. This is the way I usually do things, where I'll put a video up concerning a particular concept. That way it makes it a little bit easier. That way you can learn it on your own, but also you can go back and review any of these topics, later on, because I will have them all on first class. So that, let's say you want to review something, down the lines, especially when the exam starts coming up, you will be able to do that by going back to these videos. Anyways, what I want to do first is just go over significant figures, and some of the rules that are involved with them. At times this can get a little bit confusing, so I want to try to show you, might be a better way of thinking of all this. At first it might seem a little bit more confusing this way than actually going and memorizing the rules, but for some, or for most, this might actually be the best way of doing it. So first rule is just basically all non-zero digits are significant. So any number between 1 through 9 you would count as a significant figure. If you were given a value, that you had to figure out the number of significant figures of that value. So for example, 8.23, you have 3 non-zero digits there, so all 3 of those would be considered significant. So you'd have 3 significant figures for that particular number. Now, as far as 0 goes, though, zeros have a couple of rules that you have to follow in order to be able to figure out if they're significant or not, because they're not always significant. The first rule for 0 is just if it's trapped between 2 whole numbers or a whole number and a decimal point in that order, you would consider them to be significant. So for example, 9003, in this case you have the 9, the 3, and then the 2 zeros trapped in between those 2 numbers. So those you would consider to be significant, and so you would consider this to be 4 significant figures within that particular value. Now, if you had something along the lines of the other half of that rule, if you had 70.4 like that, that one you would also consider significant because of the fact that it's trapped between a whole number and a decimal point in that order. It has to be in that order, or else it's not always going to be considered a significant number. Alright, these next couple of rules are just a combination of the list of rules that you might have to figure out whether or not 0 is significant or not when you're looking at a measurement that you get from the lab. The first rule is just basically, if theoretically you were to take away those zeros in that number, it doesn't change the number at all, you would consider those as significant, because now what they're basically showing you are just the accuracy of that piece of equipment. What I mean by this, alright, so in this example, first off, just to explain this part of it that you have, exception to this rule is just basically this 0 right here you would never count as significant, because it's just basically a placeholder. It's just showing you that you have a decimal number in this case, so you would never count that as significant ever. But the main zeros that we're looking at in this case are these at the very end, which you have the number 0.22400. If you were to go and take those numbers out, or take those zeros out, does that change the number at all? No, it's still going to be 0.224. You're not really changing anything. Those zeros are just basically there to show you that that was the accuracy of the piece of equipment that you used within that lab. Was to that 5th decimal point. So you do have to count all of these digits, and so in this case you would have a total of 5 significant figures with this particular number. Now in this case, again, you have 73.000. If you were to go and take away those zeros, again, theoretically, we're not touching the number at all, but theoretically, if you were to take away those zeros, would that change the number at all? No, it's still going to be 73 no matter what you do. Again, those zeros are just basically showing you the accuracy of that piece of equipment that you're using. And so in this case, you would have 5 significant figures. So concerning scientific notation, you're never going to have to look at the times 10 to the whatever, because that doesn't come into play when you're dealing with significant figures. The only thing that you need to concern yourself about is the beginning number. So in this case, it's 8.20. Again, if you were to apply the rule that we've been talking about, look at the 0. Does that change the number in any way? No, it's still going to be 8.2 no matter what you do. That 0 is just there to show you the accuracy of the piece of equipment that you use to measure that number. And so in this case, you would have 3 significant figures. You would count that 0. Now moving on to the next rule, where in this case now we're looking at numbers where if you were to go and cross off the 0, they do change what the number looks like. So you would not consider them to be significant because now they're just something called a placeholder, where they're holding that number to a particular spot, such as the thousandths place or the hundredths place, that type of deal. For example, in this case we have 9,000. If theoretically we were to go and cross off those zeros, does that change the number? In this case, yes, because now it looks like 9, not 9,000 anymore. So whenever that happens, you don't count those numbers, those zeros, because they are just placeholder zeros. And so you would consider this one to be one significant figure in that value. In this next example, again, go through and look at your zeros and try to figure out theoretically if you were to get rid of them, would they change the number? Right now you have 0.009877. If you were to go and delete those zeros out, would that change the number? Again, yes, because it would no longer be that 0.009877. It would now be 9,877. So you would be changing the number. So in this case, you wouldn't count those zeros, and instead you would say that this number has 4 significant figures to it. So those are basically the rules that you need to know for significant figures. And again, I try to combine things together to make it a little easier. If by some chance this isn't helping you out and you need to look at the rules themselves, go into your textbook and look at those and memorize them, and maybe then it might be better for you to do it that way.